My name is Madison Glenn, and I conducted a Summer Fellows and Honors Research project alongside my research advisor, Dr. Kate Anderson, looking at the relationship between recognition of affective prosody, or tone of voice, and autistic symptoms in the typically developing population. Further, differences in tone of voice were assessed when presented with background noise. Emotions are a part of everyday interactions, and many emotions are displayed in conversation. It is important to be able to recognize these emotions in order to have adequate social interactions with others. As an example of emotion and tone of voice, I will play the word bicycle in two emotional tones. You will likely be able to identify the emotional tone in each sound clip.
Bicycle. Bicycle.
Without any prompting, you likely identified the first clip as happy and the second clip as sad. What you just did by determining the emotion portrayed in each sound clip is known as affective prosody perception. Affective prosody perception is defined as the ability to understand emotions that are conveyed in speech. Emotion can be detected in language because of the specific acoustic properties that each emotion has, and because of these properties, affective prosody perception is possible without knowing the language that is being spoken. Because affective prosody perception transcends native language, many studies across different parts of the world have been able to use similar tasks when assessing this ability. This is generally referred to as a vocal emotion recognition task, or VER task. The standard way to assess performance is generally by measuring percent accuracy on a forced choice task that typically involves 4 emotions that participants can select from. The most common emotions assessed tend to be happiness, sadness, fear, and anger. The yellow box can help to explain how the VER task works. A participant would hear a stimuli and then be asked to respond with which emotion they believed was conveyed in that stimuli. The participant would choose between the 4 options of happy, sad, angry, or fearful. One of the more recent applications with VER task is to study affective prosody in autism spectrum disorder, or ASD. ASD is a neurodevelopmental disorder that is classified in the DSM-5 by restricted and fixated interests and social communication impairments. Individuals with ASD are known to have difficulty with social interactions, as it is one type of social communication impairment. It is beneficial for researchers to see if affective prosody is part of what is causing impairments for those with ASD, as consistent evidence does suggest that individuals with ASD do exhibit affective prosody impairments. As I said previously, there is research to support the idea that individuals with ASD have deficits in affective prosody perception. ASD is a neurodevelopmental disorder that involves impaired social interactions. The graph shown on this slide represents data from Ollermans and colleagues that assessed both accuracy and speed of VER performance amongst several populations. One finding from this study showed that the amount of time it took for individuals with ASD to identify the emotion portrayed in an affective prosody recognition task was significantly higher in comparison to the control group. Similarly, those with ASD also produced more errors when trying to identify emotions. Further, those with ASD also made more errors than their unaffected siblings who did not exhibit ASD symptoms despite being biologically related. Therefore, these results collectively show that ASD seems to alter one's ability to detect emotion with the same speed and accuracy as those who do not have this diagnosis. While this is representative of data from one study, several studies have found similar results that show abnormalities in emotion recognition for those with ASD. Affective prosody deficiencies is only one tendency that those with ASD are likely to have. However, autistic tendencies can also be seen in the typically developing population. The AQ, or Autism Spectrum Quotient, is an instrument used to measure the degree to which typically developing individuals have autistic tendencies. The AQ has 50 questions in which individuals can answer with definitely agree, slightly disagree, or definitely disagree. Some sample items from this measure can be seen at the bottom of the screen. The AQ is a sensitive measure and it can show differences between similar groups. For example, in Figure 1, the graph shows that those with high functioning autism and Asperger's differ significantly from the control. Although the symptoms of those with these diagnoses may not be severe, they still exhibit autistic tendencies to a high enough degree to differ significantly from the control. However, there is still overlap between the groups, which shows that even those in the control who don't have a diagnosis can still exhibit autistic tendencies on some sort of continuum. Our study was divided into two experiments. The purpose of experiment 1 was to validate the use of our stimuli and ensure that the emotional tone of each stimuli was readily recognizable. We hypothesized that VER performance would be significantly greater than chance for all participants. The purpose of experiment 2 was to correlate AQ score with VER task performance using those validated stimuli. We hypothesized that there would be a significant negative correlation between AQ score and VER task performance, meaning that as AQ scores went up and individuals exhibited more autistic traits, they would have lower VER performance. During Summer Fellows of 2019, we completed Experiment 1. The aim of Experiment 1 was to have our participants identify emotions portrayed in the recorded words we used as stimuli in order to validate that the emotions in those stimuli were readily recognizable. During Experiment 1, participants were informed of their consent and allowed to ask any questions about the study. Next, they completed one block of 40 trials in a VER task. They listened to each of the 40 stimuli individually and then responded verbally after each trial with the emotion that they thought was portrayed, which was either happy, sad, angry, or fearful. When the 40 trials were complete, the participant was debriefed. Stimuli for Experiment 1 consisted of spoken, neutral, nonsense words that were half spoken by female and half spoken by male to decrease the impact of pitch of voice on the results. The participant's task was to recognize the emotion that was portrayed in each trial. The emotions of happy, sad, angry, and fearful were each tested, but each trial only portrayed one emotion. The recorded nonsense words consisted of Hebrew phonemes that we were given permission to use and have been used in previous work. There was one block of 40 trials. This is an example of what one of the stimuli portraying the emotion of happy from Experiment 1 sounded like.
Doof.
The results of Experiment 1 showed that average performance on the VER task was significantly greater than chance, with chance being 25%. As you can see in the chart, mean overall performance was 75.58%. This average was not only significantly greater than chance, but also indicated that participants were accurate in recognizing emotions portrayed in a majority of the trials. These results therefore showed that the emotions portrayed in the stimuli were indeed recognizable by participants, supporting our initial hypothesis and the use of these stimuli in future VER testing, and therefore were able to be paired with background babble and used in Experiment 2. During the fall of 2019, we completed Experiment 2. The aim of Experiment 2 was to determine the nature of the relationship between autistic traits and affective prosody perception. During Experiment 2, participants were informed of their consent and allowed to ask any questions about the study. Next, they completed the AQ measure. After the AQ measure was completed, participants completed 12 practice trials to get used to the VER task. After the practice trials, participants completed 2 blocks of 40 experimental trials. An intake form asking about demographic information and if the participant or anyone in their family had received a diagnosis of ASD or another disability was completed by participants before they were debriefed. The same stimuli were used in Experiment 2 as in Experiment 1, but neutral background babble was added and played simultaneously as the nonsense words. The neutral background babble was added to simulate real life situations because there is typically almost always some type of background noise during social interactions. This is an example of one of the stimuli used in Experiment 2. It is the same stimuli from Experiment 1, but the background babble is added. Participants completed 1 block of 12 practice trials to get used to the task, and then completed 2 blocks of 40 experimental trials. Each stimulus was repeated 2 times. The stimuli in each block of trials was in a pseudo-random order. Our hypothesis that there would be a significant negative correlation between AQ score and VER task performance was not supported. No significant correlation was found, indicating a lack of relationship between degree of autistic tendencies in the general population and the ability to understand emotion and tone of voice. Our study was the first to assess VER performance in a more ecologically valid context, so we aimed to determine if VER performance changes as a function of the added background babble. Our results showed that overall VER performance with no background babble was marginally significantly lower than performance with background babble, suggesting that the ability to understand emotion and tone of voice may differ depending on the listening environment. Several key findings from this study add to our understanding of affective prosody perception in the context of ASD symptoms. First, no significant correlation was found between AQ score and VER task performance in our study. Because of this result, we concluded that VER performance abnormalities seen in previous work may only be present when ASD symptoms reach a diagnostic level. Additionally, because VER performance with babble was higher than performance without babble, we concluded that more typical situations where background noise was present at the same time as the spoken stimulus may result in greater accuracy in determining which emotion is present in the speaker's tone of voice. Therefore, it may be possible that this is a more ecologically valid scenario that listeners are more accustomed to using in everyday life, as there is often some type of background noise when individuals are verbally interacting with others. However, a larger sample would be necessary in order to confirm this idea. Based on our findings, previous work that showed impairments in affective prosody among those with ASD should be conducted again with background babble to determine if these impairments are specific to different listening environments. I would like to thank the PC Summer Fellows Program and the Psychology Department for funding my research. If you'd like any further explanation on any of the material in this slideshow, my references are listed on this slide. Thank you for your time, and I look forward to speaking with you in the Q&A session.